Hello, assalamu alaikum. How are you all? I hope you all are doing very good. So today's session would be about 5G initial registration signaling analysis. The objective of the session is describe the functions of the registration procedure, especially when it comes to 5G, the request coming from the UE or the fixed router going towards the core network, how it interacts with the different elements within the core network, and what goes inside the parameters for each of the requests, how each of the entities are selected during this process, which will help you in order to understand the flow. Those of you who don't know me, my name is Taha Sajid, and I'm a technical lead in Huawei, responsible for 5G operation planning and solutions. Also responsible for the security aspect, 5G network deployment. So this is one of the series of my 5G training, and I'll continue to post similar sessions, which you will be not finding on Google or YouTube. Because you can say what I believe is that a lot of since we are evolving towards the 5G and a lot of CSPs are adapting 5G, so understanding the flows is important in order if you need to, let's say, build on some different use cases, then understanding the core is very important. Okay, and please do subscribe and follow my channel. I'll keep posting such videos. Okay, let us start. So the registration overview, for example, if we talk about 5G registration, how is the registration is similar to 4G? The only difference is that with the 5G, in the 5G registration, it's not involved the PDU session establishment with the registration procedure. The PDU session, like for example, if you need to browse a session, that comes under the management of under the different request, not comes under the initial registration session. Okay. UE network to use network services after the registration is complete. The network obtains the real-time UE location and capabilities, and the UE can directly initiate a PDU session establishment procedure. Okay, so this is what it happens that the UE has, obtains all the information. For example, 5G GUI or the IP details or the session, the security context, all of the things UE downloaded the acceptance. So once the registration process is accepted, but the session management comes on a different request. The AMF and the UE create mobility management context. This is also one of the, the outcomes of the registration procedure. NAS signaling is protected through security context. So like for example, any signaling that happens between the UE and the core network is protected, is having another layer of security in the 5G, which will be going in more details in the next slides about different parameters and how it the security is different from 4G. And mobility context is understandable that if the UE needs to move to a different AMF, so the UE, the mobility management has to be transferred to that AMF, or you can say the MME, as if you think about 4G. So this is what is basically the outcomes of the registration procedure. So the trigger conditions is basically 4 trigger conditions we are seeing in 5G. The first is the initial registration, which is the similar procedure as on the 4G network. This procedure is triggered when a UE register within the 5Gs. So the initial registration on the 5G decouples the mobility management and session management and does not involve PDU session establishment. This is what we have discussed previously. The second thing is the mobility registration update. For example, if the UE is moving to a different location, which comes under the new AMF or a different AMF, then the mobility registration take place for the different G-Node B in the RAN side. This procedure is triggered when a UE is in the CM connected or in the CM idle state, moves to a TA outside the UE registration area. So either the UE is in the CM connected and in the CM idle state, or it moves to a T outside the UE registration area. So there are different states. This is the CM connected. CM idle is similar to 4G, but you can just think of like, for example, if you are having your mobile phone switched on, so you will be in a CM connected state. But if you will directly switched off your phone, your status on the AMF goes to the CM idle state, in which it is like the paging request will not be responded back from the UE or from the CPE, for example, in a fixed time frame. So this is for the mobility registration update. Then, for example, also, the UE needs to update its capabilities or protocol parameters, although it stays within the registration area. So, if the UE has, updates its capabilities, for example, if it's using a different RAD, for example, or if he is using a different APN, then also the mobility registration update takes place. Then we know that periodic registration update is there, which is controlled by the timer. In the initial registration message, there's a timer, like a mobility timer that is being configured on the MME or on the AMF in 5G. So and it determines that after how long the AMF or the MME will be going to register the user. It depends on different CSPs, but usually it is 24 hours. We have set this timer. Yeah, it's like T3512 or T2102. So I'll take you through the configuration of this. We'll cover the traces part. Okay, and then we have emergency registration procedure. So we have four types of registration procedure. So looking at the flow of this one, the different entities involved over here. So for example, we have UE, RAN is G node B, the new AMF and the old AMF. If we are having two AMF, for example, and this user is moving from one AMF to another AMF. Then we have PCRF. In 5G, it is similar to, we are calling PCRF Pcf. We have SMF, which is responsible for the session management of the user. You can think of as P gateway C. Then we have AUSF and we have UDM. So AUSF here, this entity is an added layer of protection we added in 5G. It was not there in 4G. So what it does actually, we will cover in the security or the authentication management. But just to give you a high level, once the authentication vectors are generated from HSS/UDM, then it helps to generate signed response, which then goes back to the UE and calculated from the UE side. Then it matches, and if it matches, then the authentication is considered to be successful. The AUSF actually bridges the gap between the AMF, you can say, and the UDM, and includes some more authentication vectors, which helps in giving more security to the flow of the messages. Okay, so cover that in the next slide. Okay, so just to take you through step by step, the registration accept message, the registration request message is the first message that will come from the UE. The AMF selection, if you see over here, usually determine or you can say responsible or based on the radio type. For example, normally in the 5G SA network that we are having, we have binded the tags, the tracking area code with the G node Bs, and those G node Bs are mapped under the AMF. So for example, the AMF selection for the UE, which belongs to one tag, is predefined. At this tag, this G node B, which is having this amount of users, will be going to this AMF or will be going to a different AMF. So this depends on the network policy or the network design. So once, for example, if you are sending a registration request to a new AMF which does not have your initial context value, then it will request the old AMF to transfer the information. So this information usually contains the SUPI information or the integrity parameters or the UE capabilities, which is mapped with a context ID. And the new AMF or any AMF which the user will be Yeah. So there was a little bit of disconnection. Apologies for that. So basically, what we were discussing is the red side after the AMF is being selected, or it's like it's predefined from the UE side. So basically, if you are the UE, if you are a you have the SIM connected on your mobile, so the SIM exactly knows that which AMF to goes to. Even in the initial registration procedure, you know because after the registration, once the registration is completed, you get the 5G GUTI, which has the AVA, which has the AMF information, But also in the initial registration, usually it is predefined that this UE comes under this G node B, is coming under this G node B. This G node B has different tags associated with this. So, and this tags is defined on the AMF that which will go to AMF1, for example, or AMF2. Okay. So once the registration request sends from Gnode B to the AMF, AMF checks the security context or the initial context ID. If that is similar to what is being requested, and it can retrieve all the information. But if it doesn't retrieve, it send a request to the old AMF to give the information such as SUPI or the UE capabilities, then the identity request message sends to UE, in which the identity response is the IVA information of the UE. It comes, which comes to the AUSF selection. Okay, AUSF is because the IVA information is you can if you are having, let's say, one AUSF in your network, then by default, all the requests will be going to that EUSF. However, you can control the EUF selection from the IMEI, okay, which will work as same as the EIR, in your network, in which it will be one IMEI information can goes to that for the authentication and for the security purposes. Then once that authentication security happens and the response matches the integrity of the platform, is UE is being verified, all the checks performed, then the registration complete notify message goes from new AMF to the old AMF that okay, registration has been completed and you can remove all the details for the user. Okay, and then the identity request response message also in response of this initial message of request, then it also goes from the new AMF to the user. From message 7, the 11th message is the response of this message number 7. Okay, here the important thing to note is for example, if you need to whitelist or blacklist any IMEI information, and you have an EIR, you can configure the AMF to route the request to the EIR. You can configure this factor parameter in your network as well. Then the UDM selection is basically is also by default. If you are having one UDM, for example, you know that from AMF, which UDM you have to go to, and there is also entity which is NRF in the network, which is the discovery function. So all the NFs you see over here, PCRF, SMF, UDM, all these entities register themselves in NRF. So for example, if the AMF needs to go to the UDM, and it doesn't know the location, then it sends the request to NRF, and the NRF will give the direction that please go to this UDM, because based on the initial request of AMF. For example, if the user has, if you have selected that okay, this UDM can carry or would be responsible to process this MZ information, this provisioning details, all the things, then it will go to that UDM. So you can configure the routing as per your design. Okay, so once the request goes to UDM, then basically, once you are defining the subscriber, I'll show you subscriber over here. Just the UDM profile, which will give you a better indication and better concept. Just let me log into one portal. Uh, Okay, if I show you this information for SIM, then you can be able to understand. So once you define any SIM in your network, you define on HSS and UDM. I don't know why I'm saying HSS again and again, but in 5G it is UDM. Okay, so this details of the profile you configure over here. So for example, this detail once you configure the AM data, which you see over here. Uh, Yeah, the dynamic status information of AMF. All the AMF data which has been populated over here is being done by the AMF.
Hello, I think it's okay. It's just showing me this data. Yeah. So if you see this data is being defined initially with a SIM, and the message that you are see this data. Okay. So the message that you see over here, that the ECM registration message or the registration message and the SDM get message, subscribe message, all these messages are being sent by the AMF to get the details from UDM. Okay, and I'll go to the details in each of the parameter details, but just to give you a high level overview. Then the PCF selection is basically if the user or the AMF wants to, or in the design of your network you are restricting some tags or some areas for the UE to access, so you can configure that parameters in the PCRF, and during the registration procedure the AMF will query the PCF, and if there is a policy it will download that policy in the AMF to restrict the user based on some policy related things based on tag or based on some rules. You can reconfigure that, and you can download that into the AMF. Then what happens, then once that is done, if you have a rule, then you have to also update the SMF for that thing, and once that is done, it will be also notified from SMF to UDM to UDG. Okay, this N3 IWF, what you are seeing over here is basically for the non 3GPP access request that the AMF receives. So if you have at the N3 IWF entity, and this will be the mobility request, the N2 request will go to that platform, and then the response will be getting from there. So this is an extra layer which is responsible for non-3GPP access. Then similarly, this ECM registration and the SDM subscribe unsubscribe messages happens between the AMF and the UDM to register something new or to notify or to get the information or something, which we will cover that later. Once all is this thing done, the registration accept message is being sent to the UE with a policy association establishment message also sends to the from new AMF to the PCF, and the registration is completed, and this all is the same messages. So this is just a high level overview about the registration procedure in 5G. Now getting into the parameters details. The registration request. So the registration request contains the access network parameters, the registration request. The access network parameters include SUSI, which is the encrypted IMSI, or the 5G GUTI, if this is the second request into the for the new AMF. Okay, but the initial request contains the SUSI, which is the encrypted IMSI, and this we will see in the latest slides that uh, from SUSI, the derivation of IMSI will be done by the extra one entity, which is ARPF, I think, uh, which deconceals the SUSI into the IMSI, into the actual IMSI, which we are calling as SUPI. Okay, so this is we'll see. It contains the selected PLMN ID. What PLMN you are using, the requested NSSI. So usually if you are not having the network slicing enabled on your platform, you are using the default slice ID. Establishment cause, what is the cause? If the registration request message does not contain the 5G GUTI or 5G GUTI does not identify a valid AMF, the RAN selects the AMF based on the RAT type and the requested NSSI. But RAN selects the AMF. You can also configure the RAN to select the AMF based on the tracking area code or in the RAN type. as it depends on the design of your network. Okay, the key parameters in the registration request message contains the registration type. Uh, it's a mobility registration or the initial registration or what. The follow-on request that do we have any, let's say, in the registration, once the registration accept message happens, what it contains. It would be waiting for any other request, or this will be the final request. Okay, the 5G capability, what it contains requested all this information. If you see over here, the registration request message can be of different types, as what we have discussed. From the registration request, you can have all of these messages, which will be determined by these bits. So, for example, 001 is the initial registration. If the bit contains 010, then it is a mobility registration updating message. Okay, so this is what it contains. Registration type, initial registration 001, which you see over here. The same thing. Registration request message also, for example, if there is this parameter on the follow-on request pending is 1, it means that the UE does not carry a list of PDO sessions to be activated, but carries an emergency service request to be processed, or any pending uplink signaling request message. This parameters prevents the AMF from directly releasing signaling connection. So if you see this one message, it means that the AMF will not release the message. There is some message which is pending. So AMF will continue the signaling message towards the G node B and the UE. The mobility management 5G capability also having this thing like what. So for example, if your handover attached message or S1 mode is enabled, what is the capability of the UE for the registration, so in some cases, if your handset do not support this sort of things, it will be considered as 00. Okay, this is the request to NSSI. The slicing ID. One user under one DNN can be configured 8 types of slices. But if you're using different DNNs on different slicing, you can configure up to 16 slices. Okay, the UE context transfer response message. This is once if you need to transfer if you are having the request of the new AMF, and the new AMF does not contain your all related information. For example, the 5G CUTI, the complete registration request message. This is not contained. So it queries the old AMF to give you to retrieve that information. However, there is one important thing. If you are having the UDSF, there is one parameter, for example, over here, if you see. Yeah, if you're having UDSF in your network, so you don't have to. It is basically a gateway over here, and there is all MMEs who will come under that UDSF. So instead of AMF asking another AMF to give me the information, it will query the UDSF, and all the information related to the context will be delivered from UDSF. Okay, so if you have UDSF in your network, your job will be much more easier, and the signaling will be less. Okay, this is the same thing. Initial entity response message. So for example, if you the AMF does not contain the IMEI related information, or if the UE does not provide the SUSI in the registration request message, or the old AMF does not return the SUPI message, the new AMF sends an identity request message, which means that please give me the SUSI or the SUPI information. The UE respond with an identity response message carrying the SUSI information. So this is also a good step over here. See, if you see over here, this is the encrypted form. Okay, and in 5G we using SUSI, we are not sending the IMSI as a plain text message. So it is always in the encrypted form. Coming to the security procedure is compared to 4G and 5G. If you see over here, let's discuss first 4G. So the attached request message, if you see from UE to MME, it contains IMSI or GUTI value. Then the response would be then identity identification optional IMSI or IME. It happens between the UE and MME. Then the authentication happens between you using the EPS aka protocol between the UE, MME, and the HSS. And if the authentication response is successful, it grants the signed response matches between the UE and the HSS what is being configured, so the authentication is successful. But there is also another thing, which is the NAS security algorithm negotiation, which happens, which you configure on MME, what encryption, integrity, protection, or confidentiality you want to achieve in your network. So this is the same over here in 4G and 5G as well. However, there is some extra algorithms that are being added on 5G when it comes to NAS signaling. Okay, the registration acceptance is the same. So if you see the difference over here, SUPI or the IMSI is changed over here to SUSI, which is the encrypted IMSI. There is one extra parameter over here which is added, which is AUSF, which is responsible to store the signed responses, to help generating the authentication vectors, to calculate the signed responses, and to deliver that message towards UE and the UDM. Okay, and is also responsible to deconceal the SUSI into IMSI, so that is what it contains. And then the NAS security algorithm also contains some extra parameters which are not there in the 4G security procedure. Summing it up, the UE identity is just a comparison. The UE identity is confidential, which means that it is in the encrypted form. You cannot see it. The network contains identity, the UE, and needs to verify it. If the network cannot identify the UE and needs to verify it, so it again initiate the integrity procedure in the NAS signaling message between the AMF and the UE. The UE and network check whether they are secure and legal to each other. The UE negotiate the network about how to protect message content from being obtained by the and how to know whether a message is tampered with. Identity confidentiality, the network assigns a temporary identity to the UE, which is the GUTI value, which is same in the 4G as 5G. So this is, you can say this is the same over here, but some extra parameters are added in the 5G for the integrity in order to have more layers of security. Normally in 4G we are using 128 bits in the encryption, but in 5G we can use up to 256 bits, and then there is an extra layer of authentication happen between in the registration and in the session management message, which we'll discuss later. Authentication security, if you're seeing this list ng user sec para, this is configured on the AMF, on the MME, in which you can see that what algorithms are there in your network will be used to exchange and to encrypt the traffic, what sort of encryption algorithms are there, authentication event in which the integrity check will be performed between the UE and the network, that whether the UE is what is being requesting the initial request or it has changed or what, so if the parameters are not there or if something missing, then the UE cannot access the network. Okay, so this is, you can see all these parameters, for example, in the AMF. Let me show you the AMF information also. Just hold on a minute. So long. 93. It is good to actually also see in the commands and configuration. This will help you in better understanding the scenarios, and check yourself that what you have configured in your network. So for example, checking this parameter, we have to log into AMF and see what's been there. Just hold on. Goes to normal commands. sng users, yeah, this one. If you see over here, you can see this configured on the AMF, which is the MME in 4G. Okay, so this is what is being configured over here. Going back to where we have started. Okay, so this is the authentication and security. What it means, the function is if integrity check is not performed on the registration request message or the check fails, the new AMF initiates the authentication procedure. So this is the, it will happen on the initial registration. If the AMF will changes, or if the EPS to 5Gs registration take place for 5G NSA or for 4G services or even for the voice services. So let us see this flow of authentication, initial authentication method. So the UE sends the SUSI message to the SEAF. Okay, the and SEAF sends the authentication request message, contains the security number or name, serial number name or security number name. Okay, it depends on your configuration. Then the AUSF, once it gets the authentication request message, it sends the SUSI or SUPI to UDM. And UDM, inside UDM there is ARPF, which I have actually given you a brief that it helps to reconcile the IMSI message from the SUSI. Then for SUSI, SUPI deconcealment happens. Then the authentication method selection, that which authentication method are you selecting. Okay, so for example, if you see this message, authentication request message, you can see that the SUSI is sent with the serving network name, okay, which is the realm name of the network. Then what happens once the registration request goes to UDM, it generates an authentication vector which contains 5G HE is the home environment authentication vector, and the SUPI information which it generates from the SUSI. Okay, this ARPF. Then once it reaches the AUSF, it stores the X response or the signed response and calculate the H, which is the XOR, which implements the XOR or some more your mathematical computation on the response to calculate HX response. Okay, and this, by the way, this 5G HE contains random number, authentication number, and signed response along with this K or the K value of the, or the key value of the AUSF. Okay, so what happens after that? Once it calculates the HXRS, it sends that response message to SEAF. Okay, this response message contains 5G SE, the serving environment authentication vector. So the difference between this serving can be changed. For example, you can use the home UDM, but the serving or the AUSF can be of a roaming operator, you know. So that what it means by a serving environment authentication vector. 5G SE AV, which contains the same thing, just an addition of random authentication number, and instead of XRES, it puts its own HXRS, which is the hex or the generated by AUSF, the response, you know, the HX response. Then once it reaches the SEF, it sends the request, the authentication request, back to the UE to calculate the authentication response. Okay, and once this authentication response is calculated over here, the SEF actually compares that calculates HRS and compared to HXRS, you know, because the HRS response is given by the user, the UE, and if it's compared to HRS, if it's successful, then authentication will be successful over here. The response, the UE authentication request message then from SEF reaches to AUSF. It's to verify the response. Then again, some authentication response message is coming from the result, that whether the comparison is successful. It comes with the results with SUPI and the K value, the key value of the SEF, you know. So this is the same message which you see over here, the UE context response message. Okay, you can see over here it contains a random number, HX star, and authentication number, which is the same over here. Authentication response you can see over here. If you want to the request message, it also contains a random authentication parameter. So if you see that, it is basically the same. In addition of some extra parameters, some sign response, the value is changing. The parameters from 128 bits goes to 256 bits. And like the addition of some new nodes coming, like the SEAF and the AUSF, other than thing, mostly is the same as compared to 4G. So the response parameter, this is just the trace messages that I'm showing you. Same as also here, if the response confirms or the response between the UE and the SEAF and the USF matches, so it gives the authentication success message, which you can see in that trace as well over here, and the SUPI is also coming with that success message. So EAP, aka authentication is the same, and we are putting a dash over here, which is usually is coming on 5G, and it contains basically the random number, authentication number, and the signed response, which is having also the CK, and this CK dash and the IK dash is being calculated using this random authentication and the signed response over here. Okay, which is then sent to the UE to calculate the signed response from their end, and once it matches, it's then we consider authentication as successful. Okay. Uh, what else? So AUSF notifying the UDM of the authentication result over here, which is result confirmation request. The UDM stores authentication status of the UE, the confirmation response it gives, and the UDM authorizes subsequent procedure. Example from AMF as defined in section based on the UE authentication status stored on step 2. Okay, so this is just, it is the notification sent from the UDM towards the AMF. Okay, so this is what happens in the authentication procedure. Now the NAS signaling, ciphering, and integrity protection. If you see over here, the AMF starts the integrity procedure by setting the UE security capability, encryption, integrity protection algorithm for network selection. The UE then starts the integrity check, matches security capabilities, starts ciphering and integrity protection. Once it's complete, the result sends back to AMF. So if it's, for example, matches it, then the integrity will be successful. So it means that the information that is being sent from the UE to the AMF is protected, and it's not being tampered with. So this is the procedure that the AMF does in the network, okay, to protect the NAS signaling layer. And this parameters is the security mode parameter. This is, we have already shown you that this is all the encryption algorithms. AMF return UE security capabilities helps a UE to determine whether its own capabilities have been tampered with. List NGP policy if you are having some policy related things in your data. So this is the same things that this all trace messages contains all the security capabilities, and if any of the things are changed, it will be reflected, and the integrity flow will not be completed. Okay, security mode complete over here. If you see this message, then this message is this message over here, which shows that IMEI is this, the IMEI body is this, and the NAS signaling containers is this message. So if the initial NAS message sent by the UE is not protected, the security mode complete message carries the NAS message contains the complete initial NAS message. So if it's not completed, or if it's changed, then it is easily easily catched. Okay, so this is the initial registration message, it completes over here. Then the ECM registration is basically the same data that I show you, that the AM data that you have configured for the user in the HSS profile. It actually asks the AMF queries that data from the UDM, that please give me the information which you have configured. And in the ECM registration message also, the deregistration call back URI. This is the AMF tells the UDM that, okay, if you want to notify me something, please use this address to notify me something, to notify me about any status changes or something, and I'll be also using that URI to call you, or if there is a status on the UE which is changed. Then the GOMU value, which contains the PLMN ID, AMF ID, this information goes to the UDM so that UDM can register the AMF details, the RAT type, what it supports, the dual registration flag MME or AMF dual registration indication the if it supports the dual registration or not. This is also very important if you are, for example, using the NSA network or the 4G network also, in which you are connecting your AMF to MME. So if you're supporting, for example, N26 interface, then it also be notified over here. Yeah, so this is the AMF instance ID is the instance ID, or AMF. Every AMF has the different or has its unique instance ID, and this is how you can determine that which AMF is there or has been sending the request to. Response message from the UDM carries the same information on a registration success. The UDM returns the response body that contains the created AMF 3GP access registration resource. This is the message. SDM get message is that please give me the information that you have configured. For example, the AM data information basically. So the AMF sends the AMF ID subscription data types key for each subscription data types, and in the response, if you see over here, you will get the message of access and mobility subscription data, SMF selection subscription data. Okay, this results the give the SMF selection basically it also gives the SM data, that which SMF the binding of DNN is to which SMF and which SMF to query. But usually if it does not contain, then the AMF sends the get response or again query the UDM to give the SMF information. For in some scenarios, the AMF goes to NRF to give me the information, and SMF has already given all its information to actually NRF, that once the request comes for that criteria, please give that request to me. Okay, so this is depends on the design of the network. EM data information, which I show you earlier, the SM data information, SDM response also, this is the same. This is, by the way, the speed, the AMBX, the aggregated maximum bit rate uplink and downlink. This is the speed that we have configured, but usually in the network, we are giving the QoS from the PCRF, and we are defining GBR, the non-GBR, the different QI profiles based on the package details. And if that is defined in PCRF, this will not be applicable. Okay, so if the PCRF profile is not there, then you can see this information, and this will be applicable in the network. Okay, so I'll go into the details of this one once we will cover the session management, once we will do the session management session. Okay, this is the default the slicing ID, the DNN type, the local area breakout, or all the profiles related to the SM data. The SDM subscribe message also, once the SDM get response message is delivered to the AMF, then the SDM subscribe message comes from the AMF to the UDM that okay, I have subscribed to you, and the response of the message will also come back from the UDM. The UDM returns the response body that contains the created resources. Okay, so this is all the URIs that has been configured. AM policy association is the message. For example, if the AMF has a policy that to allow certain tags or to put a rule based on certain G node Bs for the UE, this is the AM policy association establishment message comes from the PCRF to the AMF. But usually, normal scenarios, we don't have any policies configured for the AMF. So this is, if you don't have any policy for the AMF, then it will be considered as the blank, and it will not be any of the information coming over here. Okay, this is the same. If you want to, let's say, block some areas, or you have to have different quality of service profile on different areas with different triggers, you can configure that in your PCRF for AMF. Okay, then once all these things are done, then the initial contact setup request message goes from the new AMF to the RAN that okay, we need to registration, we need to set up a context between you and us. For example, the AMF and the Gnode is that whenever you send the request, please use this context ID to query us, and that all information will be related to that context ID. For example, if you see the trace, it contains the TA allowed TIs, the PLM entity, the tag, the T3512 timer, which is the paging timer, which we have configured for the mobility management of the user, the RRC status, the notification that the UE state transition notification request, that in which states the UE will be changed. For example, it will go to SSE mode 1, 2, 3, or the RRC status would be what, so this is all the mobility related things. Initial context setup request continued. This is just the extension of this. The GUAMI, which is the PLM identity, the AMF region, which is contained in the GUTI message, the ID of the AMF, which UE registers. Okay, ID of allowed network slice of the UE, the security key, all this message goes to the registration accept message. Okay, when the registration is accepted, the important parameters, the message the AMF will send to the UE is the 5G GUTI, the TA list, the allowed rejected configured SSI, the T3512 value, the 5GS network feature support. Okay, so this is all what we get from the accept message. This is, if you see over here, this is the same thing. So as it depends on, these are different parameters for different use cases, for different scenarios. So it depends on your design and your customer requirement and what things you are supporting. But the 5GS network feature support can be from 3GPP to normal to MC to MF to different, except it depends on which you support and what is the design of your network, or whether you have configured or not. Policy association establishment, this is the same that we have tell you that if you are having, for example, the UE, because this parameter is usually not there in the AMF, but if you are configuring this parameter, then the request for the policy control goes to the VPCF, which is the visitor PCRF, and then it goes to the home PCRF, and you can set that whether you can create a policy association or not. Okay, if the UE policy association or not. If it's yes, then it will be following this flow. Okay, for the UE policy association establishment. So that's about it. There is one thing, for example, if you need to configure different rules based on the slicing types, here we will be configuring the URSP rule, which is, for example, if you need to send the request of your session establishment or the PDU session to different indicators. Okay, this we will be covering in the session management session, in which we will be discussing different session based on the slicing type, the DNN. If for example in one network slice you want to configure one DNN with SSE mode 3, and in another session of PDU you want to go to the slice 2 with DNN 2 with SSE mode 3. So how that works, or how that flow comes from the UE towards that network. Okay, so we will be covering that in more details once we will covering the session management slides. Thank you very much for being with me in this session. I know it's a lot of technical things are there, and in my next session, what I'll do, I'll just give you the traces, show you the traces from the live network, that for any session management or for any initial registration, how the parameters changes if you are configuring different parameters, and how all this is related. And please do tell me in your comments if you have any questions, or if you want to have more explanation on any of the slides or any of the parts. I'll be happy to discuss with you. And please follow my channel, and please you can subscribe my channel. And if you want to have any of the discussions with me, you can connect with me on LinkedIn or directly message me on the comments. Okay, thank you very much. See you next time. Allah Hafiz. Bye bye.